So I'm going to talk about this for a few minutes, and then we'll split up into pairs, and I'll ask you to go through these instructions. So let's have a look at, I think, this example. Let's make this a bit bigger so we can have a look at it together. So do you remember the fun times we're having with Bob's Bagels? I hope so. I hope that brings up some merry memories. So let's go back to that domain for a quick second, all right? We won't spend that long on it, but it might give you some nostalgia. These are our three user stories. As a customer, so I can get a bagel, I want to add a bagel to my basket. As a customer, so I can know what bagel I have, I want to be able to choose a type of bagel. And I want to get a count of the number of bagels in my basket. So a very, very simple example. But imagine we wanted to write an application that could store this data in a database. And so we would always be able to come back and see what's currently in our basket, what bagels are in our basket. All right. So let's think about how we can use this approach called a class responsibility collaborator card to help model this for us. And the important part is this collaborator. What classes do we have and which classes are they going to collaborate with? And then how can we use that to infer what our tables are going to look like? So let's take this and let's play around on our mirror board. Let's put that over here. So things that we can pick out straight away from these requirements are we have two nouns here popping up again and again, all right, bagels and baskets. Choose types of bagels and add bagels to basket. So one way we could model this is we're going to have two cards, all right, one, and let's see, I guess we could probably put that in a slightly different place to make sense of the space that I have. Let's just duplicate you. Great. So usually we split them up into the class. So this class, let's say it's going to be our basket. And this class here is going to be my bagel. And let's focus on, maybe let's focus on bagel to begin with. What does bagel need to, what's its responsibilities? If we look through the user stories, let's say this is going to be responsibilities. Fun word to spell. I want you all to choose a type of bagel. So if we think about responsibilities, the first one will be probably will be responsible for its type. You want to counter the number of bagels in my basket. I mean, that's pretty much all that it needs to really know about. All right. Now, the bagel doesn't have any collaborators. It's just a bagel. All right. That's all it needs. All it needs to be. So, in terms of its collaborators, there we are. None. There are no collaborators, right? It doesn't need any information about anything else. Let's look at our basket. Basket is responsible for, well, let's add in the same color here, collaborators and responsibilities. Here we need to have a count of bagels. And for the collaborators, therefore, it needs to know about bagels. So by organizing your classes in terms of their responsibilities and collaborators, you'll get a sense of which objects depend on each other. And this will help us form an idea of what tables we need and how they're going to be associated with each other. So in this very simple example, we would then think about, okay, so we have these two classes, what are the respective tables going to look like? So if we draw out another set of tables, let's say here, 1 and 2, and let's say this top one's going to be basket, and we'll call this baskets as its table, and this is going to be bagels. Now, we're familiar with the idea that we need to have a primary key in our tables now. So if we give both of these an ID column, and I'm going to give it a different color to say that this is specifically the PK indicates primary key, all right? ID is going to be the primary key. It's how we're going to find different rows in the table by its primary key, and how we associate tables together by its primary key. Now, let's start off with the basket at the moment. No, actually, let's keep that one to last time. Let's look at the bagels. What's the bagels table going to look like? Well, its responsibility, it has to know what type it is. So let's add that as a column. Type. Let's give an example. So let's say, for example, let's have a bagel in here. This is like an everything bagel. So we have one bagel here. How are we going to show the association between the baskets and the bagels? Well, let's create a basket first. So imagine we had a basket. What column am I using here? 1. So at the moment, all we have in here is a basket with an ID of 1 to represent an individual basket. How are we going to say, let's say we can create 2 bagels. Let's say we're going to have a second bagel, and this is going to be an onion bagel. How are we going to show that these 2 bagels are in this basket? How are we going to associate these records together? Well, if you look at the collaborators, it'll give you a sense of the relationship, but the counterintuitive thing is that this information here is going to be represented actually in the bagels table. So ordinarily people will think about, okay, for baskets, maybe we could store some kind of array of bagels. So you'd have something like, I don't know, a bagels column and have like all the IDs. Oh, that's an E. And say, for example, let's have like that, the IDs of bagels 1 and 2. But this is not the correct way to store this information. Instead, we store the information in the opposite way. We store the information here. We add a third column, like so, and we call this the basket ID. And so if these 2 bagels are in basket number of ID 1, we indicate so by saying this is in basket 1. So let's have a couple more sample data. Let's add a couple more baskets. Let's add one more basket. So let's have a second basket, ID 2, and let's add another bagel, 3, and let's call this a cheese bagel, because that's clearly a thing. And therefore, this would be ID 2. Right? This is how we represent that bagel belongs in basket of ID 2. So the tricky thing here, or the counterintuitive thing, is when we use our class responsibility collaborator cards, wherever we've defined what the collaborator is, we provide that information in the table of the collaborator. So we call this a relationship, a one-to-many relationship. A basket has many bagels, but a bagel will always belong to a basket. And so this is, when you think about the relationship, a belongs to relationship will always have a foreign key. So this here is the foreign key that relates to this primary key. By specifying that in your table, these things always needs to match. This foreign key looks at this primary key, all right, which is the column ID. They don't always have to be ID columns. You can create keys on any column. In general, they should be, where possible, be unique. But the most conventional way of doing this is always to use your foreign keys on the primary key, which is an ID column. So when we think about one-to-many relationships, first we start off thinking about what are the classes from our requirements, what are their responsibilities, and what are their collaborators. And when we can think about the collaborator in this situation where the bagel doesn't have any collaborators, but basket does, we can call this a one-to-many, and then think about who has many and who belongs to what. All right, so in this case, if we write out the sentence, which is always good practice to do so, we would say something like, basket has many bagels, whereas a bagel belongs to a basket. And again, when you see a belongs to, this is where we store the information in the table. All right, we don't store the has many. Now, notice I haven't kept any thing in my table for the count of bagels. We don't need to, because the source of truth is just simply already stored in the table. I can do a count from the information here. So at runtime, I can calculate it. I don't need to store it. Right? If I store it and then I remove a row of remove a bagel, I would then also have to update that column. So I would store that truth in two places, which would get out of sync. So the count would just always be, I do a select by baskets, or select bagels where the basket ID is 1, and I'll get 2 records, and that'll be my count. So I don't need to store this data. Not all responsibilities need to be persisted. You can always calculate them. Right? But the type does need to be stored. Okay, so this is a demonstration of going from a set of requirements, a very simple set of requirements, thinking about the classes, the responsibilities, the collaborators, thinking about the has many and belongs to, which way round do they go, finding that belongs to relationship, and then encoding that in the table as a foreign key based on the parent primary key. Something like this, I think we've already just done. And this is the example for you to have a look at. You can always go back to this example. So what you're going to do is something very similar, slightly more a complicated domain. You're going to go through and use these cards, this approach to model the domain, and then create your database structure. All right, so what I want to see by the end of this session is a set of CRC cards, and a set of tables that look something like this. All right, so you have two things to show, from cards to some diagrams of tables. You can, why did I get back there? You can think about labeling your primary keys and your foreign keys, and then writing out those sentences for the associations. You will need not just the one-to-many, but there will also be a many-to-many relationship that you might be able to spot in these requirements. The first step is to go through as many of these as possible, use these user stories, think about the cards that you'll need, what are the classes, what are their responsibilities, which classes do they need to collaborate with, form your associations, what belongs to what has many of what, and then draw out your tables with the right information. So here's a set of stories to go through and infer the database structure from, all right? And then we'll gather back together and discuss different ways that we've done this. So we'll pair up, and you'll grab one of these lovely little white spaces and go through creating your diagrams. Any questions what you're going to do over the next 45 minutes? Let's get breakout rooms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 8 rooms. Okie doke. I will open up all the rooms. Go ahead.